Hi, I'm Justus Winn-Howard.
And I'm Zach Robinson.
And today we're going to be learning about first and second derivative tests.
Alright, so on the board here we drew an example function. And on this we have 4 points of interest. And basically what that means is that you'll see we have one hump here. It's kind of bad writing. One hump here. One hump here. And one hump here. And what these are called are relative minimums and relative maximums. So right here we have a relative maximum because it's higher than this relative minimum, and another relative maximum and another relative minimum. And what the first and second derivative test will do is, using the first derivative test, we'll find exactly where these humps are.
And for the second derivative test, we'll figure out if the concave is up or down. So in order to do the first derivative test, we first have to derive this function. So we could do this using the power rule. So negative 2x squared, we'll derive that first. 2 times negative 2 becomes negative 4x, and then if we subtract 1 from the original exponent, which is 2, you get 1. So you just get negative 4x, and then we derive x right here, which becomes 1. Negative 4x plus 1, and 3 becomes 0. Alright, so this is our derived function. Alright, and now to find exactly where the hump is located, we first make this equation equal to 0. So we have negative 4x plus 1 is equal to 0. And then we would simplify just like any other equation. So we would subtract 1 from both sides. We would have negative 4x is equal to negative 1. And then we divide negative 4 by both sides to get x by itself. And we have x is equal to 1 over 4. And that is the location of the first hump, like Zach was talking about earlier.
Okay, so now moving on to the second derivative test, all we're doing is taking this derivative and we're deriving it one more time, second derivative. So we took this equation, put it over here, and once we derive it, it's pretty easy. We end up with negative 4 plus 1, 1 derived is just 0, so we have negative 4. And since this is a negative, using the second derivative test, we found out that if we were to graph this, it would look like a concave down graph. So something kind of like this. So when our final answer is a negative, it concaves down, and when our answer is a positive, it would concave up the opposite way.
And that is how and that is how first and second derivative tests are used when looking at functions and their derivatives. I'm Justus Winn-Howard.
And I'm Zach Robinson.
Thanks for watching.
This becomes 0. So we have...
Okay. Wow.
No, to go together. No, to go together. No, to go together. No, to go together.
Function. Okay. Hold on. Stuffy.